We said that energy was important in understanding matter. Energy is involved in chemical and physical changes. So here's an important idea. Systems with high potential energy have a tendency to change in a way that lowers their potential energy. It doesn't mean that they always do that, but they tend to do that. When I dropped the dry erase marker, it had higher potential energy to start with. When I let go of it, it changed in a way that lowered its potential energy. Was that a physical change or a chemical change? It was a physical change, because the marker is still a marker, right? It was just on the floor after that. It's a change, though, because it had less energy afterwards. So objects or systems that have high potential energy tend to be unstable. You guys ever watch cartoons? Did you ever watch, like, Bugs Bunny and Roadrunner and stuff? A lot of those old cartoons, there were a lot of anvils and pianos that were high up in the air, right? Those things are unstable, and they have a lot of potential energy. They tend to fall down, and whatever character it is, splat, flat as a pancake. High potential energy, unstable, going to low potential energy. Some chemical substances have high potential energy. Remember, chemical energy is a form of potential energy. So an example is TNT, trinitrotoluene. Dynamite, right? TNT, it's explosive. It's got a lot of stored chemical energy in it. And you give it a little spark, and what happens? It explodes. It reacts in a way that lowers its potential energy. Here's a couple new words. Exothermic and endothermic. And we need to understand what these guys mean. Exothermic and endothermic. So we often do a lot of things with prefixes. So here we have, these words are similar, right? But they have different beginnings, different prefixes. We have exo and endo. Well, exo means out, right? Oh wow, our exit sign is missing. I'm sure that's some sort of code violation. Most classrooms have a sign above the door that says exit, right? What does that mean? This is the way out. Exothermic. Thermic is relating to heat or energy. So an exothermic process is one in which heat exits. The prefix endo is like the word in. Here's energy coming in. So in an exothermic reaction, we have energy being released to the surroundings, and an endothermic reaction, we have energy coming in. So in this graph here, we see, I can't see what I'm doing here. This graph shows energy going up as we go up on the page. So in an exothermic reaction, the reactants start with high potential energy, and the products have lower energy. And this is how things normally work. This is usual. That the reactants have a higher energy, and they change in a way to lower their potential energy. Where did the energy go? It didn't disappear. It was released to the surroundings. The energy went out of the reaction. This is the opposite situation, an endothermic. Down here, pointing in the wrong place. Down here, an endothermic reaction. Here, the reactants have lower energy, and the products have higher energy. This is a process which is absorbing energy, because for the products to have higher potential energy, they must have gotten that energy from something or somewhere. It didn't come out of nowhere. Now, some endothermic processes do happen spontaneously, but in general, things tend to go from high energy to low energy. And this kind of reminds me of my experience with teenage guys. No offense to you who may be teenage guys, but my observation is they'll sometimes be very high energy. They go to football practice, go do all kinds of crazy things. They always come home, and where do they go? Flat out in bed, laying down. Texting people or watching TV or listening to music. They'll get up and they just have this tremendous ability to sleep. It's really mind-boggling. They sleep. low energy. And you can think of chemicals that way too. The normal thing, the thing they're going towards is low energy. So here's an example. We're supposed to classify each change as exothermic or endothermic. Heat or energy being released or absorbed. So wood burning in a fire, that's exothermic. We have experience with that. You burn wood, heat comes off, right? That's one of the main reasons we burn wood. How about ice melting? Endothermic. As you put an ice cube on your hand, imagine putting an ice cube on your hand. How does it feel? It feels cold. Why does it feel cold? Because there is heat energy going from your hand into the ice cube. What would cause the ice cube to melt faster? Put more heat into it, right? Light a candle under it. Put it on a hot plate. Put more energy into it. So ice melting is endothermic. It's absorbing energy. How about water freezing into ice? This is the opposite. It's exo. This one's harder to think about. I think the best way to think about it is as the opposite of melting. Melting makes sense to us. We're putting energy in to melt it. How do you freeze something? You stick it in the freezer, right? What's your freezer do? Your freezer is actively pulling heat out of the inside of the freezer. How it does that is a fascinating process, which is a different subject. But it's pulling energy out. So something freezing is exothermic. Does that happen spontaneously at room temperature? No. No, it doesn't. This has an interesting application to life here in the valley. I just saw on my phone there's a freeze warning tonight for the Reedley area. You know, the trees have started blooming early, and now we're getting cold weather again. It's not good. What do farmers do when there's a freeze warning? They irrigate, right? You get the field wet. You like to have standing water out there. How is that going to help? You might say, well, you know, the water's warmer when it comes out of the ground. Yeah, but it's going to cool down, and then it's going to be just as cold as the air. How is that going to help your trees not to freeze? Water freezing is an exothermic process. As water freezes, energy has to be removed. And as we'll find out later, when water freezes, the temperature, it starts to freeze at 0 degrees Celsius or 32 Fahrenheit, and it will stay at that temperature until enough energy has been removed for all of it to freeze, and then the temperature drops. So basically, by having water in your field, even if it's partially frozen, you've got this big mass that is staying at 32 degrees Celsius. You just need to keep your trees above, 26 or so to keep the oranges from freezing. So here's the water moderating the temperature. And then if you get some wind machines in there and take this 32-degree air from up off the ground and blow it around your field a little bit, you can moderate the temperature in the orchard and keep your trees from freezing. And it's chemistry. Okay, enough of that. Natural gas burning, exothermic, endothermic. Exothermic. Sometimes we have a little bit of a misconception that all exothermic processes are warm, that there's heat given off. And that's not necessarily true. It could be a different form of energy as well. Light is a form of energy. What about one of those glow sticks? You sell them at the dollar store. You break it and it glows, it gives off light. Exothermic or endothermic? There's no heat involved, but there's energy. Light energy is being given off. It's an exothermic reaction.